Okay, let's give this a whirl, folks. First time using this option on my iPad for recording, so we'll see how well this goes. So chapter 6, rational expressions and equations. You should have your notes outlined in front of you. We're going to do a couple of examples here in 6.1, and then you'll do some work in your workbook. Okay. So I'm continuing with chapter 6 because it's directly related to all the factoring that we've just done. So all of that practice of that factoring is going to definitely help for this unit. So it's a nice little carryover instead of doing trig or the other quadratics unit in between these two. Although we're still going to need to know some factoring aspects when we do the other quadratics unit. So 6.1 is equivalent rational expressions. Equivalent rational expressions is actually just a fancy term for fractions or equivalent fractions. So really, this 2 over 3 is a rational expression. It's a rational expression because it can be defined as, or any rational number is defined as a over b. So as soon as I can write anything as a fraction, it's a rational number. Okay? Now what we're going to do though is we're going to take this simple 2 over 3 idea and we're going to start to include our polynomials. Okay? So the biggest thing, or one of the biggest things to remember, is that whenever we have fractions, especially if we're dealing with variables, for example, 3 over x, remember we saw in other places where we had those, what did we call them? Not non-permissible values, but values that make the expression defined. When we had our radicals, our roots, we had x plus 3 on the inside of that radical. The radicand was x plus 3. So we have to actually do these kinds of definitions again. So when we have polynomials or rational expressions with a polynomial or a variable in the denominator, we have to define variables. Now in this unit, we actually call them something a little bit different. We call them non-permissible values. What values make these expressions undefined? So as our first start, what value can we put in for x that makes this not work? So that makes it undefined or not possible to do. And hopefully you may remember that as soon as we make that x value a 0, that means we get 3 over 0, and that is undefined. Okay? So we can't have a denominator of 0. As soon as we do, we get that undefined expression. You can put it in your calculator, you'll get an error, okay? But you'll get that undefined value. Okay, so we cannot have our denominator equal to 0. That's what determining these non-permissible values is. What makes these expressions undefined? Okay, so that's what we're going to have a look at today. That's just the first step. Okay, so it says determine the non-permissible values for each rational expression. So when we're looking at A here, in order to determine what those non-permissible values are, we have to first factor these polynomials. So x squared minus x minus 6, x squared minus x minus 6, this is factorable. We look for two numbers that multiply together to give negative 6. Those same two numbers add together to give negative 1. Those numbers are negative 3 and 2. We can factor this by inspection. We can say, well, that's x squared. Sorry, not x squared, x minus 3. X plus 2. So now we can put that in as our denominator. We have x squared plus 2 all over x minus 3, x plus 2. Now to determine our non-permissible values, we say, well, what values can we put in for x that makes these things 0? So what we're going to use again is our zero product law. And remember that our zero product law means that if we make either one of these things 0, then our denominator is going to be 0, and then that makes this undefined. So you take each of those, you take your x plus x minus 3. What is going to make that value 0? And then you solve for x. Add 3, I get x equals 3. So as soon as I say that, that's the value that this is, it's a non-permissible value. So x cannot equal 0. Sometimes I even start my non-permissibles by saying, well, that can't equal 0. Because as soon as that equals 0, my denominator is 0, and then I have an undefined expression. So there is one non-permissible value. My other one comes from the x plus 2. So I take my x plus 2 and I say, well, that cannot equal 0 either. Because as soon as it does, I have a non-permissible value or an undefined expression. So then I subtract 2, I solve for x minus 2. X cannot equal negative 2. So my non-permissible values, and I write this, I go non-permissible values are a couple of ways you could write it. So my non-permissibles, you can write 2 and not 2, negative 2 and 3, or you can say x cannot equal negative 2 and 3. Either one of those is fine as long as you're indicating that it's a non-permissible value or it's a value that x cannot be. Okay? I'm good with either form. Doesn't matter to me. Okay. Hopefully that wasn't too bad. That's all we're doing at this point is we are just determining non-permissible values. We're trying to figure out what makes these expressions not work. We're going to do one other little thing, but that's the main part of section 1 here. So now we go on to question B. What values make this expression undefined, or what are the non-permissible values? Well, if we look at x squared plus 1, this does not factor, does it? Okay. So now we have to try those other methods that we know in order to solve for x. We're still trying to determine what our non-permissible value is. So what can I put in for x that makes that x squared plus 1 not equal to 0? And then I start to solve. Okay? So I would subtract 1 from both sides, subtract 1, I get x squared is equal to negative 1, and then I would square root both sides. So I get x is equal to, technically plus or minus the square root of negative 1, and here you should be saying, hey, wait a minute, this doesn't work. This is not possible, right? Because we cannot take the square root of a negative value. So in this instance, there isn't anything that we can put in for x that makes this equal to 0. Okay? So this means that all values are possible. Okay? All values are possible, or no non-permissible values. Okay? So if you can't actually solve for a value, that means everything is okay. So there's no non-permissible values. Okay. Example 2. This concept in example 2 says writing equivalent forms of rational expressions. This is nothing new that we've seen before. It's just a variation of equivalent fractions. And in order to simplify our rational expressions, we have to understand how this works. Okay? So it says use multiplication and division to write two equivalent forms of the rational expression. So let me give you a different example using fractions that we already know. Okay? So let's look at the fraction 4 over 6. Okay? Can you write two equivalent forms of 4 over 6? Hopefully you can, or you say you can. I could also say, well, you know what? 4 over 6 is a fraction. That fraction reduces. It reduces by a factor of 2. So if I divide both the top and the bottom by 2, I get 2 over 3. There is an equivalent form of that fraction that we got from using division. Okay? 4 over 6 could also be an equivalent fraction if we use some kind of multiplication. Well, what if we increased those by a factor of 2? So I multiply by 2, multiplied by 2, I get 8 over 12. Also an equivalent form of 4 over 6. And again, you can see if you wanted to reduce 8 over 12, you would actually get to 2 over 3. Divide by 4. You get 2 over 3. So those three fractions, 4 over 6, 2 over 3, and 8 over 12, are all equivalent forms of that same fraction of 2 over 3. We got one of them. by dividing. We got the other one by multiplying. We can do the same thing with rational expressions or with our polynomials. Okay? It says use multiplication to write two equivalent forms of the rational expression. Multiplication and division. Okay? So if we use multiplication, that means that all I have to do is decide on something that I could multiply both the numerator and denominator by in order to change this fraction or rational expression. So I could say 3 bracket x plus 2, there's my polynomial as it stands right, or my rational expression as it stands right now, x plus 2, x minus 4. Well, what if I multiplied by, let's say 7. I could say now that 21 x plus 2 over 7 x plus 2 x minus 4 is an equivalent expression because I've multiplied by the numerator and the denominator by the same value. I could also go 3 bracket x plus 2 over x plus 2 x minus 4. Say, you know what? I want to multiply the top and bottom by x minus 7. There's another equivalent form by multiplication. Now we won't normally, well, sometimes we'll do that in order to do addition and subtraction of rational expressions. We need to create those equivalent fractions. But for the first section that we're going to do tomorrow, 6.2, multiplying and dividing, we're going to be simplifying like this. I'll show you. So now we need to do this using division. So now I have 3 bracket x plus 2 over x plus 2 bracket x minus 4. Oops, minus 4. So now by division, well, what can I divide out of this that's going to make this an equivalent expression? Hopefully you see that this x plus 2 and this x plus 2 are the same. So I could rewrite this as an intermediate step. I say, you know what? This is the same as 3 bracket x plus 2 over x minus 4 bracket x plus 2. And you can see that these will cancel. That entire bracket cancels. Okay? Not just the 2's, not just the x's, but that entire binomial. Okay? So these cancel, these reduce, these disappear, and I'm just left with 3 over x minus 4. Okay? That is an equivalent expression using division. Okay? Now for this question, hopefully that's okay. That's all you really need to get out of this question. But because we've already learned and talked about these non-permissible values, from now on, all the way through the entire unit, if you ever are given a rational expression in which there is a variable in the denominator, you have to define the variables. You have to determine what the non-permissible values are. Always, 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 always. So just to make sure that we're going to stay on that same track, what are my non-permissible values? Well, I can't have x plus 2. That cannot equal 0. So I solve for x. Minus 2, x cannot equal negative 2. Boom. X minus 4 cannot equal 0. Solve for x. Plus 4, x cannot equal 4. There's my two non-permissible values. Now, it's going to get to the point where we do these so often that I don't necessarily need to see this work. I do, though, need to see you define these values. They have to be noted or listed somewhere, okay? Sometimes there's going to be some work to get to these, like we may have to factor this thing, just like we did up here. And when that happens, then that's the work that you need to show off to the side somewhere. But make sure that as soon as you start these questions, that you determine what those non-permissible values are. Okay? Over the page, example 3. It says write each rational expression in simplest form. So in simplest form is just like the simplest form of that fraction 4 over 6. I'm going to switch colors. That fraction of 4 over 6, okay, is not a correct final answer because that's a fraction that can be reduced. So this becomes 2 over 3. Same with these rational expressions. Simplest form means that they have to be reduced. Okay? So you just reduce your fractions. Or in the case of question A, you just use your exponent laws and what you know about reducing fractions and reduce and simplify. 15x squared y z cubed over 20xyz. You should hopefully see that 15 over 20 reduces to, because they both divide by 5, gives us 3 over 4. And then you use your exponent laws for the rest. X squared divided by x is just x. Y divided by y, those cancel, gives me 1, it disappears. X cubed to divide, or sorry, not x, z cubed divided by z is z squared. Okay. And then that's questions finished. That is simplified. Okay. But again, because we have variables in the denominator, we have to define our variables. Okay? We have to find those non-permissible values. So what values make this denominator 0? So x cannot equal 0. As soon as it's 0, the entire denominator equals 0. Y cannot equal 0, and z cannot equal 0. Okay, so we have to define or make those or state those non-permissible values all the time, even if a question doesn't say to. Okay. Question B. 3x squared minus 8x all divided by 2x. Our first step, we're going to do our non-permissible values. And that's simply, you can just say non-permissible values over here. What makes this 2x? I can't have that equal 0. And then I solve for x. So I divide by 2, x cannot equal 0. So there's my non-permissible value. You could do the same process over here too. 20 x, y, z cannot equal 0. Well, what makes that 0? Well, I divide by 20, x, y, z cannot equal 0. And then you just define each of those. Well, I'm going to solve for x, then that can't equal 0, y cannot equal 0, z cannot equal 0. Anytime those equal 0, then it's undefined. So the next step is now we need to simplify. In order to simplify, everything needs to be factored. As soon as we have it factored, we can start canceling and reducing, just like we reduce our fractions. I can't just simply, well, in this case I can, but I shouldn't. I can't just simply say, hey, you know what? This x is going to cancel with this x, is going to cancel with this x. Okay? I can't do that because of this subtraction sign. Okay? So what I want to do is I want to factor the numerator, factor the top, and then start to simplify or cancel. So 3x squared minus 8x, you should see that there is a GCF. The GCF is x. When I factor out an x, I get 3x minus 8 all over 2x. Now these x's can cancel. This x will cancel and simplify with this x. So I'm just left with 3x minus 8 all over 2. And I'm complete. Question C. Again, we determine our non-permissible values first. So now I have x squared minus 4. That cannot equal 0. Two ways you can go about finding these non-permissible values. I see that this factors, it's difference of squares, so it's a very quick factor. Or you can use the perfect square method as well. Either or works, okay? So I can say, well, if I'm solving this for x, I'm going to add 4 to both sides. So x squared cannot equal 4. And then I square root both sides. X cannot equal plus or minus the square root of 4, which is plus or minus 2. So x cannot equal 2 or negative 2. So my non-permissible values, plus minus 2. Okay? Or x cannot equal plus or minus 2. Either way. Okay? I prefer factoring. Because we need these factored anyway in order to simplify. So if you were going to factor this, you would say x squared minus 4 equals, cannot equal 0. You see that this is difference of squares. You should say, well, that is x plus 2, x minus 2 cannot equal 0. And you take each one of those and you solve. X plus 2 cannot equal 0. Minus 2, so x cannot equal negative 2. X minus 2 cannot equal 0. Add 2, not 4. I don't know why I wrote 4. 2, 2. X cannot equal 2. So either way, you get to the same place. Okay. I prefer factoring because as soon as we have this factored, bracket back in there, as soon as we have this factored, I can now replace that as my denominator. So now I have x squared plus 6x plus 8 all over x plus 2, x minus 2. Now in order to take the next step to simplify, I now need this part, this x squared plus 6x plus 8 factored. So again, I say, well, I'm looking for two numbers that multiply together to give 8. Those same two numbers add together to give 6. Hopefully you see fairly quickly that those numbers are 4 and 2. And I can rewrite that as x plus 4, x plus 2, all over x minus 2, and x plus 2. And then we simplify. And simplifying says, well, you know what? This x plus 2 is the same as this x plus 2. Those will cancel, those will disappear, and I'm just left with x plus 4 over x minus 2. Now remember, these are a thing technically contained in a bracket, and I cannot reduce parts of that. I cannot say, well, let me cancel this x with this x. You can't do that. That's not allowed. Okay? Because they're separated by a plus or a minus sign, this is a term, it's a binomial. You cannot do that. Now, how am I going to erase that? There we go. So that is where that question stays. Then the only thing from here is we just get a little bit more complicated with our factoring and simplifying. Okay, so question D, 16 minus x squared all over 2x squared minus 11x plus 12. Over here, I'm going to do my non-permissible values. 2x squared minus 11x plus 12. What two numbers multiply together to give me 24? Those same two numbers add together to give me negative 11, negative 8, negative 3. I can't do this by inspection, so now I'm drawing my t. 2x squared minus 8x minus 3x plus 12. Draw your t. GCF of 2x squared and 8x is 2x. That gives me x minus 4. GCF of minus 3x and 12 is minus 3. That gives me x minus 4. Look, those are the same. X minus 4. 2x minus 3. See where all this factoring work is going to be handy? There's my denominator. Now I'm saying, well, this cannot equal 0. So I go x minus 4 cannot equal 0, and I solve for x, add 4, x cannot equal 4, and I say 2x minus 3. 2x minus 3 cannot equal 0, so I add 3, so I get 2x cannot equal 3, and I divide by 2, x cannot equal 3 over 2. There are your non-permissible values. All of that work just before we even start the question. Now I've defined my non-permissible values. Now I can start to simplify. In order to simplify, we need all of the polynomials factored. So I've already factored this in determining my non-permissible values. So I can very simply say, well, this is also 16 minus x squared all over x minus 4, 2x minus 3. But I still need to factor that top part. Now that top part, you should be saying, well, that looks a lot like difference of squares, but it's backwards, isn't it? We need our x term at the beginning. So this one, because it's backwards, we have to do what we call, well, the nickname is the negative trig. Okay? The negative trig. If I factor out a negative 1, what do I get in the numerator? So if I factor out a negative 1, 16 divided by negative 1 is negative 16, minus x squared divided by negative 1 is plus x squared. And look, I'm going to write this whole intermediate step out, x minus 4, 2x minus 3. This can now be rearranged. So we get negative 1, bracket, x squared minus 16, end bracket, and I get x minus 4, 2x minus 3. Now you should be saying, hey, you know what? Now that is difference of squares. It's in the proper order. I should be able to factor that, hopefully quickly, because we've done enough of these. So I say, well, that's difference of squares. So x squared minus 16 is going to give me, wrong color. Here we go. X plus 4, x minus 4. Don't forget your negative 1 out in front, over x minus 4, 2x minus 3. And then see, these will cancel. X minus 4, x minus 4, gone, disappears, they cancel. I'm left with negative 1, bracket x plus 4, over 2x minus 3. Do not do any multiplying back in, just leave it exactly like that. Okay? So that is determining non-permissible values, simplifying your individual rational expressions. We introduced what a rational expression was and different forms of it. Okay, so there's 6.1. Pages for your questions will be noted somewhere. We'll see you next time.